We got a new cluster from procurement in 2017. Dell, Alces with AWS were the winners on that. So we had some money to do some experimentation with. And yeah, it worked relatively well. This is a target. We're not there yet. We're a long ways away from it yet. We sort of know what we want to do. It's just trying to get the people free to do it. Shortage of people is a problem. So the sort of scenarios we were looking at, cloud bursting. Now, the trouble with cloud bursting is that you need to then be able to charge people for it. So I'm using the disaster recovery as sort of a stepping stone towards doing sane cloud bursting. The other thing that we found handy was people said, oh, I need this much compute and this much memory. Really? So you can spin up some, I mean, you can do the same thing with VMware as well, and we're playing with that a bit as well, but sometimes it's easier to drop. And the cloud starts saying, okay, here's what you think you need. Does it really satisfy your needs? Experiment around, come back and tell us how you get on. And then the other thing we had was, there were some people who needed some GPUs at a time when we didn't have them available, and we could get them off onto the cloud and do GPUs. The problem with GPUs in the cloud is they are not cheap. And the other thing is, we're not doing large data transfers at the moment. We're working on our network more or less to double, quadruple our capacity into the cloud. And again, that's a work in progress as well. So cloud bursting, a lot of the stuff that Chris was just going through. Setting things up, not particularly difficult. We had this linking thing into our local cloud server, or our local on-prem Condor, but then talk off to a cloud instance that was in the cloud. The cloud instance would then spin everything up and run things there. Tied the spot market. We weren't doing as extensive, it was more experimental stuff that we were doing, so we didn't run into some of the practical things that Chris was talking about. So one of the things we did say was, don't just go for the cheapest instance, because when you try to do that, you realize, you know, they're cheap for a reason. And they take a long time to do anything. You're much better with mid-range instances oftentimes. The difference between some of the reasonable ones and the top-end node instances, when you look at time to solution overall in price, they are very, very similar. So you don't necessarily start cheap. You probably want to start mid-scope and even high scope to sort of see what's going on and help people out. We were partly motivated by people had a problem. People had deadlines. People had to do a hell of a lot of compute in a very short period of time. Epidemiological studies with blue tongue disease back. The thing is, blue tongue did not spread in the UK the way they thought it should do. It didn't spread as badly, and they were trying to understand why it wasn't worse. So there was actually quite an interesting study, and they were trying to look at how the things had propagated and what was slowing it down and use it to things. And we found, as I say, you know, the T2 medium was the cheapest, most cost-effective. But again, C4 large and C5 large, C4 large or well, C5 Starlight, were more expensive per hour, but took fewer hours. So they're very similar. And you know, so we broke things up. But the end of the story was that we were able to do in 7.5 hours what would have taken 98 days serially, and it cost $15. And the other critical thing was they got the paper submitted on time and accepted. So at the end of 2018, we thought, oh, this is really, really great. We'll be able to do all sorts of exciting things. Okay, storage, these two, there's lots of possibilities. Alces Flight cluster stuff, that worked relatively well, and we're building on that. Condor, some potential. Again, we need to work on that. And we do think there is actually a big boost that you can get from the cloud along with your on-premise stuff. But as Simon was pointing out, your on-premise HPC is custom designed, it's got an integrated network, everything is all chunked together. So what we wanted to do was we're trying to get some sort of a seamless cloud access. Okay, we're able to do that. And replicate some of the custom functionality in the cloud. We're able to do some of that. We've got the basic hooks set up for being able to do Active Directory authentication. And we've actually got the virtual private cloud set up so that when we spin stuff up, it actually appears as being part of our network. But it's still got some rough edges, and we can't really deploy onto all of those yet. And the problem is that it probably will only take a few days' time from our direct people, but they're pretty tied up. And I do think that's actually a big plus. I think sending somebody, especially on the stuff I'll be talking about in terms of cloud bursting or disaster recovery, being able to have your instances appear as if you're on your campus. Oh, and we can access license servers and stuff to make it life better. So we got fairly 70 active users, not always the same 70 from month to month, but about that many. Alces are provider of systems management, and yeah, we don't have a massive radical change on the software offerings we do. It's normally end of the first part of the year, people come and say, can you get these new applications, please? So what we want to be able to look at are sort of three things. So better resiliency, this is what I'm talking about today. Other topics that are for the future, because I think they're still important, but we haven't been able to progress on them, is trying to provide a better, more flexible environment for new users. So there's lots and lots of people we got who have never worked with command line before and saying, what the hell is this? Where's my window? And then the other thing is trying to provide better development and experimental support. So again, it's trying to be flexible on several fronts. The classic sort of thing is, you talk to you guys and say, oh yeah, we got VMware failover, and we got email failover, and we got all sorts of things failover. And you realize that now, failover in an HPC system is just not going to work, is it? Because, okay, we got two clusters, great, okay? And you're not going to have one sitting idle waiting for the other one to fail, right? I mean, that's just kind of stupid. So, okay, we'll run them after that. Well, yeah, but then you need a synchronization problem. And invariably, they're going to be different systems, and probably from different vendors. So, you can kind of do it, but trying to coordinate is tricky. And also, it does take up twice as much space and power and cooling, and lots of places don't have that. Right? We're just focusing now in a new data center move, and we're going to fix 6 water-cooled racks, and that's pretty much it. If we need more, we would need to go to AQL and Leeds or something like that. Just go to the data center or the cloud. So the idea is, well, we'd like to have some sort of a cloned environment. Now, by clone, I do not mean to bring up exactly the same number of nodes in the cloud as we have on-prem, because again, that's silly and really expensive. But you want the software environment. You want the look and feel of it. You want the texture. When people go onto the cloud environment, you want them to think they're on your local on-prem system. You don't really need to have a lot of compute sitting idle in the cloud for this, because you're just going to compute up on demand. Really, you just need to be able to have storage there. And the other thing is, it's better than that, because the main thing is once you bring up your HPC instance, you basically just need your storage in your front-end login nodes there, and maybe a very small number of compute nodes, but you can basically auto-scale that stuff. So you start to say, well, okay, we'll bring these up as we need them. And the other thing is you can try to tie in with the spot market and do other things along that sort of side. There are practical issues and limitations with that. Chris has told you on that. So again, possible way to save money when you're trying to do an emergency setup disaster recovery. You probably want to have some of the nodes not on the spot market. You want them on demand nodes. So they're more expensive, but they're going to be there and not going to disappear on your people. And how a mixture is interesting question still to be worked on. And again, as Chris mentioned, you can get very, very good price reductions on cloud instances if you're going to say, yeah, we want this for 12 months. But that only makes sense if you could use it all the time, right? Because the whole point about the cloud is you do not let resources sit idle. If they're idle, you turn them off. And this is where my thinking's evolving some. But let me stick to this story to begin with. So you look, what have you got? Well, you got your node images. Okay, well they don't change that much. They're not all that big. What are you going to dump in the cloud? And then you got your home directories. Well, that text tends to be around a terabyte-ish, small number of terabytes maybe. Well, how is that up in the cloud? Or certainly, when you spin up the resilient service, having that environment up in the cloud makes a lot of sense. Volatile areas? Yeah. That 200 terabytes up on-prem? Okay. So this could be one of the practical limitations of being able to do things in the cloud. You may not have large volumes of scratch disk available. It's not something we can work on. And certainly people say, well, can't we just put all the volatile storage in the cloud? Forget it. Okay, it's going to be slow, and God, is it going to be expensive. Okay, so this is my current understanding of the crisis. And this has actually come off the calculator from about maybe a week ago, maybe, no, 2 days ago. So elastic block storage is flat standard network. NFS connections onto your cluster environment. So with fast always, you can put in SSDs. Of course, if you have SSDs, it's more expensive. But you can, get things sorted out. And 100 gigabytes is about $8 a month. Okay, so you think, well, that's going to amount up. Okay. So you don't want that to be too big, but you want that to be practical, sensible size. If you use standard S3 storage, that's slower, but you can get anywhere in the cloud, and in fact, you can access it in lots of other places as well. Amazon's actually very, very good. If you look at what you can do with S3 storage as opposed to OneDrive, S3 just absolutely covers it in terms of accessibility. It's great. You can mount these on Linux systems and all sorts of good stuff. And again, okay, well, now you're down to about $230 a month for 100 gig. Okay, that's not bad. And then if you do intelligent tiering, so you're trying to actually sort of say, well, some stuff we actually want fairly quick access to, others we can let sort of drop off. Or infrequent access, then again you get other rates. And it's not really for HPC purposes, but if you know you've got a chunk of storage that's not going to change much, so there might be like data sets that people are reading from, but they're not updating, then you could possibly dump those into archive storage. Again, you're going to take a while to load those up in your cluster environment, but they're relatively inexpensive. That could be an option. And as I say, this is with AWS, that's where I'm most familiar with. Other vendors have similar options. That was sort of the background. The immediate problem was this. We, at the moment, have 6 racks of air-cooled compute. And we are moving into a new data center, which is basically 1 floor down. And that's got much better cooling. We can do 120 kilowatts now with water-cooled doors. More importantly, it's got UPS and diesel backup generator. So we've got always-on power for the entire data center, including the HPC. We've got an old Sandy Bridge cluster that's going to be running at the time. And what we want to try to do is augment this with a cloud environment that's similar to what our current system is, but we'll use Cascade Lake and some AMD nodes. So the Cascade Lake, 36 cores. Our compute nodes at the moment have 40 cores and 384 gig of memory. So you can't replicate that exactly, but you can kind of get close. So just to give you an idea, because slides get a bit boring after a while. So we got those air-cooled racks at the moment, and you can sort of see there's a fan trying to blow the hot air down the aisle to each other. Just to augment the fact that this is air-cooled, right? And so we want to take those. Typically the back of the rack looks like this. Okay, so there is a fair amount of networking involved because it's all, we're actually using OmniPath, but yeah, so each of these is 4 nodes. We've got 4 OmniPath cables, Ethernet cables, plus the iDRAC stuff. And you don't really want to move that yourself, so we'll get Alces to do it. So there's a bit of a challenge there, and then we'll put them into these are the back ends with the cold doors. So that's where we're going to in our new data center. Water-cooled racks like would be great. It'll be better. But there's a slight problem, right? Because when we move it, we're going to have to power it off already. And that means, this is going to take about 10 days. Okay, so nobody will be able to have cluster access for these 10 days. Right. That's why we're going to have some experiment in the cloud. So we tested this. We had a trial. In June, they were moving the power supplies from the data center over so they could actually put power into the new data center. And they said, well, we'll need to turn the building off for a day. Everything goes off, including the cluster. So we'll say, well, okay, we'll do that as a test in the cloud. And that went reasonably well. Again, because our environment set up with Alces Flight and Alces are doing the systems management, that worked fairly well. The other thing that was interesting, Alces are able to talk to Azure and Google and AWS as well. And for this time period and stuff, what we needed, AWS is better, but AWS doesn't have the fast interconnect, so we were focusing on SMB type jobs. And what we wanted to do is basically say, well, we'll have a small system available with login node storage, a tiny bit of compute for testing. We'll have that available beforehand. We'll then go into the full cloud cluster, and then we'll have a wind-up phase. So it basically trumped in terms of a preliminary small system, production system, and tail-end small system for people to be able to pull data and results off. We actually had a GPU node as well, and it turned out that was actually fairly heavy. We've got a couple of groups who are just very, very keen on deep learning with GPU for image analysis mainly. And so basically, once our local system called Barclay was up and running, because they were both Alces Flight systems, it was very, very easy for people to log on to the cloud front end, and it was very easy for them just to copy files into a mounted directory, which was on the cloud storage. So that all worked. We did not copy the home file store over, so it was just basically what users wanted to take over, plus all of the system volumes. It also set up the GoodWare environment, so that came in, and it had all of our customized GoodWare bits and pieces added in, all the different variations of CUDA and all these different bits and pieces, they were all there. We copied over all of the extra application files, basically it's vast computation, chemistry, kind of related things, main things we copied over. Also, MATLAB runtime environments, these sorts of things. A couple of little gotchas. The nodes were hyper-threaded, and so because that was then showing up as what is potentially 72 cores here, that could cause problems if people then wanted to just use 36. So we said, look, it's probably best if you need these things, ask for exclusive access so you don't end up sharing the hyperthreads with somebody thinking they're going to be real cores. Access is via SSH. As I say, it'd be nice to be able to set things up ultimately so we're able to use Active Directory authentication. But we had SSH keys because that was the underlying mechanism. Basically, we used the underlying mechanism that Alces use on the compute nodes. And we replicated that across. And then the other thing, for security reasons, the cluster basically could only be accessed if you were physically on-prem or via the VPN to appear on-prem. But our VPN is set up intelligently so that it says, oh, you're using a University of Liverpool address, fine, then we'll channel it through onto the virtual network. Oh, this is not the university campus network, so we will just put you through directly. And this caused a problem. So we needed, basically, if you're using the VPN, you needed to log on to a Liverpool system first, and then go again. So it's a slight issue, particularly because most of the data center went down. So it was a slight challenge. But because we replicated the runtime environment and the applications, and the module environment was more or less exactly the same, then people were able to cope with changing the partitions that they're referring to, and they're able to cope with referring to the number of cores per node and the number of nodes. Then there were a few niggles with off-campus access with SSH keys, where we were able to show them how to do it, and it worked relatively well. Because we had some VMwares that we could basically bridge through. It wasn't heavily used. The GPU node was used fairly well all the time. There were a few people that experimented with it, but again, we probably over subscribed. So we probably had more compute resources than we actually needed. When we looked at the overall costs, that about 75% of that cost wasn't the compute nodes. The GPU node, the one GPU node, actually accounted for about a fifth of it. So that shows you how expensive the GPU nodes tend to be, especially if you want V100s. Look and feel helped a lot. We had the little test nodes there available, but because they didn't support AVX 512, which Starlight does, that caused some issues. And so, okay, we're coming up, hopefully, should be sometime today, that we will actually have the cloud access, because starting on Monday, we will be powering off parts of Barclay to start moving it. So originally, when Nick asked me about giving a presentation, this was all supposed to have started on Tuesday, the 15th, but for a variety of reasons, it got pushed back. We're probably looking at around 10 days of being active. We're going for 100 gigabit InfiniBand interconnect, which means we're on Azure. Cascade Light with AMD nodes. And the AMD nodes, we thought, well, those would be good for Gaussian and little things like that. But also now with the announcement about RG2, we're saying, by the way, we say AMD nodes if you want to have an experiment with them to sort of see what nodes you're going to get. And we might be bursting onto those later on, separately. And so now we're sort of back to the getting people to transfer files over, get things started, so they start doing some tests. And we can limit the number of nodes we're going to have up, so we'll basically be doing a lot of scaling this time more, so hopefully we won't be burning cycles on things that are sitting idle, because that's not the way you do things in the cloud. We'll see how it goes, but yeah, we're not quite there yet, but it's in close. And as I say, after we've got all this done, and we sort of say, well, okay, so now we've got the new cluster in the environment, well, what are we going to do? And you sort of say, well, okay, we've got the basis of some sort of disaster recovery. Okay, the major thing there is, what storage do you move to the cloud, and when do you move it? Okay, up until a couple of days ago, I was thinking, well, we'll just basically back up into the cloud, and it'll just be, we'll pay for the cloud storage. It's not that expensive. And we'll keep it there. I'm beginning to think, well, actually, now that we've got a faster network connection into the cloud, like it'll be 40 gig, we might just want to have a staging area and orchestrate it. So actually, the storage is actually on-prem almost all the time. And it's only when the cluster goes down and shit happens, you say, oh, let's start getting that up into the cloud, and once it's there, then we start bringing up compute. Okay, so in some ways that appeals to me more than having the storage there all the time. But we'll see. And then the other critical thing is we really do need to get this sensible thing set up. And again, possibly motivated by having access to roam processors, because again, one of the advantages of dealing with people like AWS is they get the hardware before pretty much everybody else. So, oh, I want to try on the latest Cascade Lake. Okay, use this instance. I'm going to try on the latest Roam instance. Okay, try this. Okay. Roam's not quite there yet, I don't think, is it? But it'll be available very soon. So definitely experimenting with new stuff is definitely a plus for the cloud, both the AWS and Azure. And then try to do some experimentation with getting the spot market working correctly. And as I say, it's slightly tricky because there's some resources you just won't on, but other ones you're probably willing to have there. If they go, okay, that's tough, but you can resubmit and rerun. And then the other thing is then build a business case for some degree of, you really want to be able to have this level of resiliency so your researchers have got some confidence that if they have some critical stuff going on, they can actually carry on doing it. So, final slide. So what do we think is important? Well, I think the critical thing with all of this, both for cloud bursting and for disaster recovery, is have the environment look as much as similar to what you have on-prem. We're not there yet, but it really does make an awful lot of sense to try to make certain that your cloud cluster is integrated into your local environment. So take a look, take advantage of VPC kind of hooks, so it's on your network. Use active directories for authentication. Again, that gets around all sorts of storage issues. Storage, okay. As I say, I'll need to do some experimentation with this. I'm beginning to go more and more to having a local backup and basically looking at trying to orchestrate this. So yeah, the image, the basic scripting and everything to be able to fire up the cloud will be in the cloud, but that'll take up no storage at all. Then you just sort of bring the template in and start running. It really is just this terabyte or two of storage that you want to bring up. And it's going to take probably 10-15 minutes to copy it over. And you could probably do the system stuff, start bringing up compute nodes at the same time as you're copying over the user home directories. And so you think, probably you're only talking about 20-30 minutes before you're up and running, and maybe it's best to keep it on ground. And then, and then the question is okay, so you've got this disaster recovery, but you're not going to have 100 nodes in the cloud, are you? So how many make sense? And also, what interconnect are you going to be able to try to make available for people? It's interesting. We have a large number of high throughput jobs. The chemists do some very interesting combinations of their workflows are interestingly complicated. So they will go weeks where it's all high throughput stuff, hundreds and hundreds of thousands of high throughput jobs. And then they'll kick into detailed low-level modeling, which is parallel ab initio codes like that they'll then run for weeks and weeks. In some sense, the interconnect you need might depend on where those workflows are. Okay, that can be tricky, but we'll see. And auto-scaling, definite mass spot market, yeah, that's such a good way to save costs on your regular compute nodes. If you're using GPU nodes, spot market isn't great, but for regular compute nodes, spot market is really your friend. So that's more or less where we are at the moment. As I said, lots of open questions, but there's a fair number of fairly positive signs. This is why we're heading towards disaster recovery. We're not there yet, but it does look like it is something we can feasibly do.